Hi, the next topic is fitted probability and fitted curve. So recall that in linear regression model, one of the main objective to estimate parameters is to get fitted value. So y is equal to a plus bx is a fitted model, suppose. Then if we observe another observation x naught, by using estimated a and b, you can get estimated y naught. So this can be used for prediction or to calculate appropriate value for y. So this is useful. In logistic regression, that we want to do the same thing as this. But one complication is the logit function. So remember that in logistic regression, eta is linear combination of beta 1, the linear combination of x1 to xq. So this formula, but also this eta is transformed version of p. So p should be e to the power eta over 1 plus e to the power eta. So we need some transformation. Okay, so now we estimate the p. So at first we need coefficient. So we have estimated coefficient beta 0 hat and beta 1 hat and beta 2 hat from logistic regression model. So that is this coefficient LR. So this is three-dimensional vector of beta naught hat, beta 1 hat, beta 2 hat. So we define this as B. Then we count the number of observations. This is about 3,000. Then we prepare model matrix. So remember that the y was x beta, and it's the same for logistic regression case. Maybe y is replaced by eta, but the x beta part is the same. So we have to define x. So first column is intercept, so we repeat 1 n times. And the second variable is height, so height, and the third variable is cigarettes, CIGS. Then we calculate the x times beta, x times b in this notation. Okay, so here x is n by 3 matrix. Then now that we get the estimated eta, and estimated eta is in here, the n by 3 times 3 by 1, so n by 1 matrix. But we want to make this a vector, so we put as vector function to get n-dimensional vector eta. So the first 6 observations of eta are these numbers. So remember that P is transformed version of eta, and the relationship between eta and P is about this shape. So P is between 0 and 1 always, and eta is equal to 0.5. The P is equal to 0.5 if eta is equal to 0. So most estimated eta is -2 or -2.7 or something. So the most points are around here. So corresponding P will be a smaller number, you can imagine. So this is called logit function. Inverse logit function. So by using this inverse logit function, you can actually estimate the probability, P hat. And those, actually the first 6 probabilities are 0.11, 0.093, 0.059, and so on. So it ranges from maybe about 5.9% to 11.1%. So for each individual, given the height and the cigarette, the number of cigarettes smoked, probability to get the heart disease is between 6% and 11%, depending on those 2 variables. And actually this can be obtained by just fitted of LR object, logistic regression object, and we exactly get the same number. But here, the objective is to show that what's happening behind the code. So now we have finished the how to estimate fitted value. So next we think about the fitted curve for a predictor. So we want to see the risk of heart disease for by the number of cigarettes smoked per day. So for now that we ignore the height factor because it's not our interest at this point. So we fix height is equal to 70 in this slide. So 70 is the mode of the height, 70 inches. So we fix 70, then if we think about the relationship and the cigarette and the fitted probability, heart disease probability, then that becomes this curve. So that means if you smoke no cigarettes at all, then estimated probability is probably maybe 5 or 6%. But if you smoke 100 cigarettes per day, then estimated probability is probably around 40%. So it's much higher. So even though we don't have any observations around here, especially for no heart disease patients here, but based on our model assumption, if you smoke 100 cigarettes per day, then estimated probability becomes 40%. So next slide explains how this figure is generated. So at first I define the fit70 function. That is, we fix height at 70 inches. Then we calculate the estimated probability given the number of cigarettes smoked, that is x. So that is the I-logit, the inverse logit function of intercept plus beta 1 hat times 70 and beta 2 hat times the number of cigarettes. And it's important to make this function so that the x accepts a vector. So x is a scalar, then usually it's not difficult to write a function, but we have to make sure that this doesn't make error even when we plug in x is a vector. X is, for example, 1 and 10 and 100, then still it shouldn't make an error. Otherwise, we cannot use function later. And okay, so next we plot all observations using the jitter function and the plot function. Then we use curve function. This is basically similar to plot function, but it's used to generate curve without specifying the range. And we overlay the curve with the scatter plot. Yeah, so this makes this figure. So you can see how number of cigarettes and the heart disease probability are related.